Hey everyone, so I'm just going to go through a couple of the ways my turbine sucks, because there's some stuff in this that definitely can be fixed up, but it's a good thing because they're all really simple things to be fixed, and it's really nothing that's like, it means that we're getting tons of power output actually with this, but we can gain even more by fixing a couple of these really simple things. One of the biggest things going on here, and I plot twist, what I said in my last video was technically wrong. I had thought that the issue I was having with this touching off, and when I had it so that it could no longer spin without touching off on the plates here, was because this just warped and it melted some onto the end plate here, and there was some in there, and that was why it was going. And I was wrong. What ended up happening is my locking collars on here, I don't have them actually locked, so all of this was just slightly press fit together, and this ended up just becoming really loose. This was not like this the last time I took this apart. I pressed it on my nice little press. This thing was real tight. So all that really happened was this whole thing got loose. And I didn't even have to clean much off of the edge here. There was a little tiny buildup, but honestly, I think that was from the last time, and I just was lazy. So that was like the biggest thing, and so I disassembled the whole thing to have to actually get this pressed back together. But I haven't done it yet, just because I was waiting. You can see this is way looser now. Like there's a good millimeter to 2 millimeters in there. This is my hand. I can like push it back in tight against the star washers. So there's been a bunch of increase out of that. One of the other really big ways this thing is losing a lot of efficiency out of it is through these gears. I had them a little too tight last time, but we could seriously be seeing about a 10 to 20% loss just from those gears alone, especially because there's two of them on here. In the future, I plan to fix that with my axial flux design, where it'll be built into the turbine and the casing, where there'll be coils around in the casing and the magnets will be inside the turbine. It'll probably have to be in a second stage here, so it won't be anywhere near the high temperatures in the final one when we do combustion and high temperature steam. But that'll be gone. So there'll be no gear interfacing. This will just be free floating on bearings, and it'll have the magnets just all in the house. I have a video, if you see it up here, it's a long walkthrough. It's one of my older ones, so bear with it. But it goes through the smaller one that I had designed with the 4-inch and 5-inch 2-stage turbine. But it's the same thing. I can go right into this one too. Another way my turbine sucks is my motor mounts. I did not give them enough thickness inside here for, I'll see if I can't show it. I'm a little upside down for you guys, aren't I? You can see it is really thin in there. So there's like maybe a millimeter or two these motors are holding on to, or with these screws. And I've at least put 500 to 750 watts of transmission power through this, and that's just being held on by this little thing here. And if I can hold it tight, you can maybe be able to see how much it's flexing. Probably better from here. I don't know. It's probably bouncing around like crazy right now. But definitely it's flexing out of the way a lot. I can see it when I was doing my pump tests. When I was running it with the RC car motors, running it with the ESCs from the RC car motors, I could watch the motors flexing out of the way over the top of the gear. So that's giving us a ton of efficiency loss in that aspect. Another way that my turbine sucks are these bearings. You can see it's kind of starting to rust in there a little bit. I actually am surprised. I thought it was going to be more rust on the inside of this, and actually to the inside, but it's a good thing because these have rubber seals, so there's probably no rusting on the inside. They don't feel like they're rusting. They feel really nice and smooth. I believe they're packed with grease, so I think if I opened up those seals and put new put new oil in there instead of grease, and then put the seals back on, they could probably go up to a little higher RPM and probably generate a lot less heat. With that being said, I'm going to be switching over to my new bearings. These ones are a much lower profile bearing. You can see that they're much smaller. And these ones are stainless steel racers with ceramic nitride balls. I also have some stainless steel all around with some metal shields that I will eventually maybe try too, but they're a little cheaper than the ceramic ones. Another way my Tesla turbine sucks. Right now I'm not using any kind of real Labyrinth seal. I've got these grooves in here that do mesh, that they misalign with this, so they kind of interlace a little bit, but that's not doing too much for me. And my plan was to have radial Labyrinth seals, so that in between each of these I'll have another disc that'll come up maybe just a little bit more, like a millimeter or two. And what that, I have it already cut out in here, is that there's a nice little lip on this, and so that extra little Labyrinth seal sticking out will provide a resistance for air going over the end plates coming through here, because it'll have to go over this like series of labyrinths that to get out over the top of the exhaust duct here. They won't perfectly eliminate everything, but a good part about these radial Labyrinth seals is that you do build up a centrifugal head that helps aid in that. And these should be tight enough. And I don't feel like I'm getting a lot of loss over the edge here now that I've gotten this tightened up. Well, had it tightened up, but these extra radial seals will really help. And I'm going to be doing these out of Teflon. So they'll kind of also act as like bumpers. They'll be able to touch off if anything happens, if it moves too much or it needs to shake too much, or God forbid anything else happens. It'll make it so that these exhaust ducts that come out will be in the end their own little bearing or emergency bearing if anything fails, and it won't go crazy on it, and it'll come down to a slow rotating, or hopefully it'll come down to a slow stop. Another way my turbine sucks, my circular grooves. If you look on Tesla's patent, and I'll put a picture of it right up here, these circular grooves need to actually be a good deal recessed so that there can become like an actual pocket. And when the turbine spins up against it, I'm gonna see if I can't interlace this real fast. When the turbine comes up against it, there's supposed to become like a donut of air that kind of toroids in that circular groove, and it kind of helps create like an air bearing on it as well. Another type of kind of the centripetal head of that toroidal flow ends up creating a pressure which reduces overflow from the top of this turbine disc as well. So in my next one, I'll have these radial or these circular grooves done to maybe like somewhere between 1/8 of an inch and a 1/2 of an inch. I know that's a pretty big range. Or I'm sorry, 1/8 of an inch and a 1/4 inch, not 1/2 inch. These are 1/2 inch thick. But I think recessing them a bit further will really help keep these nice and true inside this case as well. Another way my turbine sucks is these radial or these Labyrinth seals that I grouped into here. I'm going to put up a little picture right here. You can see, because I took the groove and took mass out of this side of this disc, and these are flat. When it wants to spin up, because it's missing support on this side, the center of mass will want to teeter in actually, so that these little grooves allow it to kind of actually fold in. It's really good actually, because it causes the disc pack to tighten up on itself once it starts spinning up, which means it'll pull away from the wall, so it won't ever touch off. But we need those radial, or the circular grooves to be deeper so that we can get a nice band of pressure in there that helps really keep the center and eliminate flow over. Plus with these radial Labyrinth seals, we'll be able to get a lot of protection from overflow and this disc pack will always stay nice and rigid. I really thought about it. These grooves will eliminate any chance of it from flexing out that way, and it'll actually want it to always flex in. Another way my Tesla turbine is terrible. My nozzles, oh, excuse that noise. My nozzles are actually wider than my disc stack here. So that the widest of the nozzle doesn't come just slightly in here where it's got a little overhang. It actually overhangs over, so the nozzle is exposed to half of the end plate here, which actually gives it a really easy chance to go over. And I don't like that, and I'll be fixing that. But why that's happening is because I'm using the thin external pieces to work as like thin shims so that I can gradually space it out larger and larger, so it's just a perfect size in there. I've been able to like really tune it in closely because of that. But the only ones I have cut out also have the nozzle cut out and don't have this kind cut out, so that when I do put it in there as a spacer, I have to put it in the center instead of being able to put it on the outside of the nozzle case pieces, where it can actually not increase the width of the nozzle, it just increases the casing and keeps the nozzle the same width as the disc. So right now I'm actually oversizing my nozzle to this disc stack. Another way my Tesla turbine kind of sucks is that the nozzle attack angle right now for how my flow is coming in has to be far too, I'll show you on this one. It has to be far too much of an angle when it's to be the proper cutoff, that I'm not just like way too wide open. So when I have to like just pinch it so that I'm still getting a good velocity increase from the converging section of this nozzle, it's too tight, and it ends up pointing to, it creates an attack angle from the fluid that I think is coming in too much radially instead of glancing off the tips, and that's to create the like nice tight flow that I want for high velocity. But this nozzle will be great for when I do the vacuum pressure steam, because we need large volumetric flow rates for vacuum to get enough mass flow rate that we get an actual enough power output from the entropy available. So kind of a good thing, kind of a bad thing for steam later, bad thing right now for the compressed air tests we're doing and the water tests I've been doing. That could be fixed. I'm going to make it so it's not as deep, and it can be more closed off when it's not at such an angle. Another way my Tesla turbine kind of sucks, or has sucked up until this point, my flanges that have been sealing up my fluid supply to the nozzle on the actual casing right here are really thin. They're less than a 1/4 inch thick. So even though I have all these screws that are holding it pressed really tight up against the casing, it's enough that it can just flex between these. And as you can see, I'll show a picture right here from one of the last videos if you hadn't seen it. The air is just coming right on out, right past between these two holes. I'm not having any kind of leak issues anywhere else on this turbine. So I think if I just switch over to 1/2 inch flanges that make it easy to connect my fluid supply up to the turbine, that 1/2 inch thick polycarbonate will easily distribute the load of those washers, such that there's no like easy path anywhere between the screw holes for the fluid to actually go through. Now, at the very worst, I could use gaskets, but I really don't think that's necessary. Okay, I think that comes out to 10 of the ways my Tesla turbine is kind of terrible. But why that's a good thing is because all of these things are really easy to fix, and I've been able to be really successful so far with not having to do too much. Like that, to be honest, this is kind of not the greatest turbine. Like, it's got a lot of problems, and I'm getting a lot of torque, and I'm getting a lot of actual power conversion. Now, again, most of all these issues are easily solved, and I plan on fixing them in these next few days, or I'm going to try and get it done in the next day, but who knows? R&D takes its time. Can't really plan some of this, and I might come up with a new idea to fix something that I didn't think about before. Up until now, though, I'm really satisfied with this thing, and I'm pretty excited, because it just goes to show that a lot of the stuff I've been working on is really, really coming together and really You know, it's doing what I've been thinking it's gonna do.